Alright guys, so today we are working on Big X factoring and remembering how to factor. That's an important part of our curriculum. So we have all the polynomials here and then we have the answers over here. So we have to pick one of each of these to go with this guy. Okay, so let's look at number 3. So we're going to make our Big X. We're going to multiply to 20 and we're going to add to -9. So two numbers that multiply to positive 20 and add to -9. Oh, -4 and -5. So that's what I'm going to replace my two terms on the middle with, -4 and -5. So now I have n squared minus 4n minus 5n plus 20. If you remember the trick, you don't have to write this all out. You could just go to your answer. So your answer will be n minus 4 and n minus 5 because my polynomial has a leading coefficient of 1. If you don't remember though, you can always keep going. Factor out your greatest common term. So in my first two it's n, and then I have n minus 4 left. And then on my second term it will be -5, and then I have n minus 4 left. Remember, you want to take that negative because we want whatever's on the inside to match for both of those. So if I kept this as a positive 5, then this would be a -n and a positive 4, which doesn't match the other one. So I took out my negative to go with my 5. Now what I have left, I have my greatest common factor of n minus 4, and then I have n minus 5 left over, which is what I have here. Okay, and then just to prove that this actually works, we're going to factor it out so you can see. N times n is n squared, n times -5 is -5n, -4n times n is -4n, and -4 times -5 is 20. Then we have n squared minus 9n plus 20, which is what we had to start with. Okay, so number 3 matches with 14 and p. Okay, so then what do? Write the letter in the box at the bottom of the page. Oh, I think that these guys go together. So 14 is p. Okay, so then we keep going. I'll do an example when it has a leading coefficient, and then I'll talk about number 1 in a second. So we have a leading coefficient. We're going to do number 6 now. Sorry, this was number 3. Number 6. Okay, so when you have a leading coefficient, when you have a big X, you're going to start by seeing if you could, if you have any greatest common factors. Well, 3 can't go into 8 or 5, so no greatest common factors. So now we need to big X it. In order to big X, we have to multiply. So 3 times 5 is 15. So we're multiplying to get 15. And we're going to add to get our middle number, which is -8. Okay, so multiplying to 15 and adding to -8, -5, -3. Okay, so now, because this is not a leading coefficient of 1, you actually have to write it out. So it's 3n squared minus 5n minus 3n minus, plus 5. Okay, so now I take out my greatest common factor in my first two terms. So it doesn't matter what order you write this in. You can see that it would have probably been better to write this in the opposite order because I could have taken more out, but it doesn't really matter. So I'm going to take out an n, then I have 3n minus 5 left, and then I'm going to take out a -1, and that gives me 3n minus 5. I take out my greatest common factor of these guys, which is 3n minus 5, and then I'm left with n minus 1 because that's what's remaining in my next terms. Okay, and then we look here. So we've got n minus 1 and 3n minus 5. That's this guy. So 18 is s. So then we go down here. 18 is s. I love it. Okay. Now, number 1 is a special case. We love special cases. If you remember it's a special case, then you can do the special case rules. So the special case rules said square root, and then we have to figure out our signs, okay? So the square root of 4 is 2n, and the square root of 49 is 7. Okay, so think about what we're going to do. We are going to end up multiplying these guys together. Okay, and now I need to get a -49, so the only way to multiply and get a -49 is if one of them is positive and one of them is negative. Okay, since it's a square root, it's a special case, so our numbers are going to repeat. And it has no middle term, which means that the middle term was 0. So if I multiply here and I distribute this out, 2 times 2 is 4n squared. Then I have 2 times 7, which is positive 14n. Negative 7 times 2 is negative 14n, which cancels the middle terms out. And then negative 7 times positive 7 is negative 49, leaving 4n squared minus 49. So if you have a difference of perfect squares, then you write the square roots for each of them, including the n. So I took the square root of n as well and got, or the square root of n squared and got n. And then you have a positive version and a negative version in order to cancel out the middle. Okay, so then number 1 would be 9 and g. So then I would go 9 is g. All right. And the same thing happens on number 10. Let's look at number 10. So number 10 is that 1 minus 9a to the 4th. That is still a perfect square, and it's a difference of perfect squares. So you're going to have 1 minus 3a squared times 1 plus 3a squared. And do we have that? Yes, we do. 8 and n. So n is 8. Okay, so let me know if you have any more questions. Good luck on your factoring review worksheet. Have a great day, guys. Bye.